Hello, good morning. My name is Imiamo. In this video, I will explain my solution for AI programming assignment 1 question number 2 using the UCI Auto MPG dataset. The goal of this question is to process the dataset correctly, train and correct sequential deep neural network, and use it to predict the MPG vehicles. So the data set file is the data set file is auto MPG data from the UCI machine learning repository. The data include the include vehicle attributes such as the uh, such as the cylinder, displacement, horsepower, weight, accelerations, model year, origins, and names. So first of all, I'm trying to be read through. I'm trying to be load that this data and then trying to be retrieve the data, the rule structure, and then informations. So question number 8 is the drop the name and original attributes. So name is the strings identifier not using the numeric regression. Original is a categorized attribute and the assignments specifically ask for the drop it. So I remove then using the banded drop. So you maybe see that it is the auto draw. I create the value for the auto draw and then trying to be drop it. So first of all, I'm trying to be compare before drop and then after drop. So before draw, you maybe see that we have the 9 column. So after drop is reduce the 2 column, so 7. So you maybe see that is the columns. From here, no origin and the name anymore. So on top you maybe see that this one is before I drop the origin and name column. So that is the accurate data. And then this one is after I drop the model, the origin and the names. So question number 3 is the fail missing horsepower value. In the part B, the assignment states that horsepower have a 6 missing value. To fix it, I fill the missing horsepower value using the average horsepower for the respective number of the cylindrical. This means I group the data set by the cylindrical, calculate the mean horsepower per group, and then use the mean to fit the missing value. This output is to better the filling with one overall average because horsepower is strongly related to the cylindrical car. So first of all, I'm trying to be finding out the what is the six missing value. So you maybe see the horsepower. So six missing value is appear horsepower is now. So and after this one also I'm trying to be finding out what is the horsepower value is now. This one is a calculation for the average horsepower for the respective number of cylindrical. And then this one is missing horsepower value before fillings. I'm trying to be calculate the how many horsepower value it is before that is. So this one is this code is I fill the missing horsepower and then fillings for the cylindrical and then horsepower. So this one is I'm checking after I fill the average. So you maybe see that this column it is the all of the row that I insert the horsepower value. So for the question number C is a fit model yield of the 2 digit to the 4 digit. So next, the model yields attribute is stored in the 2 digit. For example, 7 mean 90 70, 82 mean 90 82. So I add 1900 to convert the yields into the 4 digit format. This ensures the yield value are consistent and earlier for the model to the interpret. So first of all, I'm trying to be see that what is the model year column appear. So you maybe see that it is all at the two digit. So I'm trying to be check that all of this model young column all at the 2 digit. So answer is yes. So before I at the compare 2 digit year to 4 digit, I'm trying to be finding out that what kind of 2 digit value have it. So they have it, the unit year is 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, and then 82. So this code is I'm trying to be convert 2 digit years to the 4 digit year. So I'm trying to be add on the 1900. So after that, I'm trying to be check what is the conversion. So you maybe see the difference. So now 70 to the 1970. So it's converted. So this one is I'm trying to be pull what is the model year column load is changing to the 1000 is changing to the 4 digit. So and after that, the part D, I'm trying to be split into 50% training and then 50% validations. After processing, I split the data set into the 50% training set, validation that I use the training test base with the test size 0.5 random state 42s. So this ensure I can be evaluate the model on the MSIN validations data. So you maybe see that training rule, validation rule are trying to be print out. So the question number D is that train the garage model sequential DNN that predict the MPG of the vehicle. So for the untrained Step one, separate features and then label. This one is a MBG is my target label Y. The all other column begin the features data X. And after that, I use the standardized scalar to scale the features value to mean 0 and then variant 1. This have training stability and then performance. And after that, for the step 3, I'm trying to be bit and then combine the model. So I'm bit a sequential model with the Dennis layout. For example, Dennis 64 ReLU, Dennis 64 ReLUs, and then Dennis 1 output layer. Since this is the regression that the output layer have 1 neurons. So I apply the model. This one is the model, the summary that I'm trying to be print out. So I combine the model using the optimizer Aiden's loose MSE, mean squared error, metric MAE, mean absolute error. Then I train the model using the fit. So you maybe see that it is I train the model that I put 100. So after training, I evaluate the model on the validation set. I report validation. So this one is I'm trying to recreate the B plot with the grad. So I report the validation loss MSE and then validation lot MAE. This value tell me how close my prediction are to real MPG values, and then lower MAE mean better average predict accuracy. So next, the question number F is printed MPG for the 10 given vehicle. Next, I use my trained DNN model for the part E to predict MPG for the 10 vehicle provided in the assignment data. So first of all, I create a new data frame containing the 10 vehicle attributes. So you maybe see that it is the data frames, and then it's coming out like that, so it is all the dense behavior details. And I apply the standard scalar using in training. So I call the model predict to obtain MPG predictions. Then I print the result for the each each vehicle. So so that is the result that I'm trying to be predict predict, and then each vehicle reserve. So now I will be identifying which part of the code I authorize, which part of the code where I use code I author is the dropping the name of the original, filling missing horsepower value by the cylindrical root mean, convert yield from 2-digit to 4-digit format, separating the dataset into the train and validation set, and then prepare features and label regressions, scale features, use the standard scalar, predict training, and then sequential DNA regression model, and predict MPG for the 10 vehicle, and print result. So go inspired, and then I use the generally I use from the I reference from the Jira dashboard, and also the lateral node, the general structure of the aura follow from the lateral node and Jira dashboards for the general structure of training scale train workflow. The current sequential model structure follows tensor flows, and then carries documentation example. So back sometimes I may require to use the ChatGPT or Google Gemini for the debugging error, generating debugging error, because I'm trying to be create the code. Sometimes the code having the error, so I need some help from the ChatGPT for the code debugging purpose only. Yeah. To conclude, I successfully proposed the auto MPG dataset, handle missing horsepower value correctly, with the years format, train a sequential DNA regression model to predict MPG, and then predict MPG for the 10 given vehicle. That's all from my assignments presentations. Thanks for watching.